Dobrý deň. Tak, a máme tu druhý blok, ktorý sa bude venovať téme, ktorú sme už otvorili, a to sú drevostavby a použitie dreva ako materiálu v stavebníctve. Ja možno začnem teda tak trošku informatívne, aj keď teraz sme to už asi dneska už aj počuli, odznelo to. Drevo je jeden z najstarších overených materiálov, poskytujúci environmentálne, ekonomické, ako aj technické výhody oproti konvenčným materiálom, ktoré používame v stavebníctve a sme na ne zvyknutí, napríklad spomínaný betón. Pre úspešnú implementáciu komerčných drevostavieb na Slovensku je potrebná nielen legislatívna úprava, ale aj dostatočná znalosť kvalitných technických riešení. Práve tie sú súčasťou tvorby ateliéru Schmidt, Lassen, architekt z Dánska. A dnes máme tu česť privítať u nás partnera tejto spoločnosti, pána Metza Kaltofta. Týmto odovzdávam slovo tebe, Oli, a poviem nám teda pár slov o ňom.
Again, I will speak in English so that Mats can check whether I'm telling the right things about him. Mats has graduated as an architect from a background as a carpenter and architectural technologist. This is obviously important, especially for the topics which we'll address today, or he will address in his presentation. He has special attention to feasibility and experience with industrial prefabrication, which he uses to create solutions that can be delivered efficiently, both in terms of time and money. In recent years, he has increasingly developed this approach within new methods for building in wood, a material that carries great potential both with regards to environmental factors, building physics and aesthetics. Since joining Schmidt Lassen in 2001, Mats has been involved in several large-scale projects across Scandinavia and is currently managing and leading the project of Rocket and Tigeli, thank you, the world's tallest residential building with a load-bearing timber structure. Mats, floor is yours.
So is this working? Yeah. Thank you so much for having me here. I'm happy to be able to share some of our thoughts on timber in general. I'm happy to be able to share experience from our practice, more than 30 years practice of building with wood and timber. And I would also like to elaborate a little bit about where we are today and why we are here today, about the history of architecture in the sense of the timber construction. But also about the background, as it was mentioned in the first lecture, that we are in Denmark already starting what I suppose that all countries have to face, to have those demands on the carbon emission. So a little bit about the background here. And then I will share some build work and explain about the this high-rise that we are doing in Switzerland as well. So a year ago, more or less, we won a competition in Switzerland in 30 kilometers away from Zurich, Winterthur. And it was the client's ambition to build the tallest all-in-all timber structure. It's supposed to be 100 meters high. This is the one that the high-rise is called the Rocket, and the low-rise is called the Tiggerlis. So I will come back to that later in the presentation in the end. But I guess this is why it's a part of the reason that I'm here today, because this got a lot of attention all over Europe, this project. But first, is this working a little bit slow? Okay, but first a little bit about who we are. We are a Danish architect company founded, let's say, almost 40 years ago. Working very internationally. We are not as big as Schmidt, we are approximately 150 employees, more or less. This is a photo taken from a study trip this summer to Oslo, where we have a big part of our work in Norway. So we were founded in Denmark. We have 2 offices in Denmark, and then we used to have an office in London, so we are working internationally, and as well an office in Shanghai, China. And our portfolio is also all around the world. Of course, the main load of our work is around Scandinavia and in Europe. But also we are working in, of course, in Asia and as far away as Australia and North America. One of the reasons that we get around into the world is actually our qualifications on libraries and public buildings. That's one of the reasons we have built libraries in New Zealand and Australia and in Canada. But we, as a firm, we have the full scale of work. We actually work from the very small projects and into master planning as well, urban planning. We span quite wide, but the main load of our work is, of course, doing buildings in the middle. The context to frame our present work is, of course, that we are facing this heavy CO2 emission that is a big threat to the globe and to our climate. And a large part of that comes, of course, from construction. And we all know now that the climate crisis is real. I think you need to be very hard-headed if you should object to that. And that has, of course, created an increasing political awareness during the last decade. We were already in the early zeros. We already had a big first take on sustainability and having a policy in the company. But we faced, as everybody did, faced the crisis in 2008, the financial crisis, and then we lost momentum in a way. But then we got started again after the crisis. But what we have seen, all of us, is this political awareness has increased, and that has actually speeded up the process. So during decades in many of these things that I'm explaining about is more or less what is our current environment in Denmark with our politics, and it's more or less the same in Scandinavia, I would say. But this is what we have experienced during the last 3-4 decades, that the codes and the standards has improved a lot in the way we produce the energy. Everything has been optimized since, I would say, the 90s, and it seems like we have reached a point where we get as good as we can, even with sustainable and renewable energy. When I came here yesterday, I drove from Austria, from Vienna, through this big area of the windmill park, and this is the way forward. So when you look at the curve, it seems like we have done well and optimized the way we produce energy, at least in Denmark. So another thing that we have optimized during the last 3 to 4 decades, since the thing that you call the oil crisis in '72, where the Arab countries closed the well, then we had got the first focus on energy and heat insulation. And since then, we have actually, as you can see, made our buildings more and more effective in regards of energy consumption, in regards of insulating the envelope, even to an extent that I would say that it's even too much how we insulate it. If you need to compare it into, or if you focus on the carbon emission that comes out of that insulation, we have reached a point where this is also at a top level. So what we are focusing now is that where we can do better now is actually on the on the resources we build into the buildings. That's what's happening right now, and that's what it's all about when we talk about embodied carbon. And worldwide, I think it's 39% of the carbon emission actually comes out of what we do in our industry. And of course, if you separate the numbers of the operating energy and carbon, that takes still a lot, the 28%, but we could work with those 11% that comes out of the embodied materials. So this is what we look into. I think in the first lecture it was mentioned that we already this year in January started to work with a restricted amount of carbon that we can build into the projects. And this is how it looks right now, that we can we need to calculate this during the process from the early stages in order to secure that we know what we are doing actually. At the moment, the target is 12 kilos per square meter, and we did the first test in the office in a very early stage. And it's not complicated to do these calculations. It's just because we don't know it. It's actually quite an easy tool to use. And but we also can see that it's not a very ambitious target, those 12 kilos per square meter. So we must speed up that process in order to get down to where it gets to be a game changer in the industry. And that doesn't happen in 25. It happens maybe in 27. There we are where we need to be, or maybe even in 29, I would say. But this is the way we work in Denmark now, and it's I can say that it's not frightening. It's not a lot of documentation. I think it's the way forward for all countries. So it's very easy for me to say, but I think it's as simple as this, that we need to replace as much as we can with wood. I mean, steel and concrete, we need it still in the foundations, in the zones that have contact with the soil and the earth and so on. But we need to change the way we build today from a concrete world into a timber world. So, and that's why I want to look a little bit back into the history and tradition, because I think that it's a personal opinion, but I think that what we see as architecture is actually, it originates from some of the earliest civilizations from Asia, and has created what all architects, the languages that we are still using. And this is typical at timber architecture, because those were resources that could be harvested, it could even be grown. And then you would, of course, lift this a little bit more fragile to moist, these constructions and structures. You would lift it up on podiums, either of earth or stone. So this is 4,000 years ago. And locally in Denmark, we have tradition that, I mean, the Greeks, and in southern countries, you can find the palace, you can find the temples in the Roman temples, the Greek temples, still more or less intact. In Denmark, buildings back from the Iron Age, they were made out of timber and wood. We can only find the black spots when we excavate areas from that time back in the Iron Age. But this is how it looked, this is how it started. It was all organic, all bio-based materials, but with a very beautiful and understandable, it's a very hard for you to see, but with a very clear structure. Even in Slovakia, in your local context, this is still, I didn't visit this, but I think that you still have these buildings in the mountain region. And so it's a part of our common building tradition that we need to refine and revisit today. So we need to look back, but we also need to look ahead. a little bit about what we have done in Schmidt Lassen. We in Denmark, though, I think it has always been a part of the building tradition to use timber and wood, even though it wasn't a special feature. It's been a local tradition. So in our short span of those almost 40 years, we have been working with timber always, and it goes from the little cottage or cabin, summer house, to the airport structure, as well as some of those examples that I will show you in a little while, smaller office buildings. Right now, our focus on trying to implement timber as the main structure, structural material, is so strong that we did 10 competition proposals last year, and out of those, 8 of them were either pure timber projects or hybrid timber and concrete projects. And so it is really something that is our main focus at the moment. So some of the examples, this is a small extension of an office building, which is actually the company that produces the Lego brick. It's probably one of the most wealthy companies in Denmark, and they had a high ambition. They wanted to go in front back then in 15 when they made the brief, and then we got the commission to do this timber CLT project. And it's hard to explain about it in these photos, but one of the things that you experience when you go there in timber structures and wooden-clad building is this amazing indoor climate and environment. It's a game changer. It's a thing that ties into the well-being of people, and that is amazing. Since we all need to do it in the near future, built with timber and wood. Another project is a very simple. It's also a prototype in our portfolio. A very simple project. It's a very small office building. It's a shared office facility, and the idea is actually quite simple. We have since I can't remember, but in my lifetime, it's always been like we have sports facilities, swimming pools, farmhouses built in this technique by frames, and similar to what some of the American cultures did back when they established the America in the countryside. And this is again very low tech, very simple, old school techniques that can be built until a certain scale. And this house is also an example. If you would have the chance to go there, it's also an example of an amazing indoor climate where you have a fully open office in 2 stories with a lot of different small companies sitting in the same building, but with no problems that we know from modern office buildings where there's a terrible acoustic, even in this one. So it's hard to explain when you show the images, but it's a real game changer. Then we have somehow scaled this up in a project in Canada, where we are working on the university campus. This is somehow more or less the same idea, but scaled up into a larger scale, 25,000 square meters. So you can see some of the interior, and the feel is more or less the same as you saw before, but now this is getting bigger. And this is a project that we are, it had its groundbreaking already, so this is going to be something that we can investigate in a couple of years. And that is also laminated timber and cross-laminated timber, all of it. Another example is a competition we won Netherlands, in Dordrecht, where they have this. All the Netherlands is, of course, as we know, below waters. So even though they have this risk of flooding, they also accepted to build in timber. The first couple of floors is built in concrete to reduce the risk when it floods, because they know that it will flood. But then we have a hybrid of timber and concrete in this town hall building. And another one in Oslo. It's unfortunately we didn't win this one, but get a second prize. But this is also an example of a big office building in the center of Oslo, where you can see more or less the same configuration with a central atrium, and then it's a system that we proposed, a system called CRE, which is one of the leading building systems in timber at the moment. A very simple system with simple elements, columns, beams, and sort of a prefabricated brick of concrete that you put on top of it in order to take those sound demands. And for now, we also the recent years we started, when we work even in competition states, we start to analyze quite early in order to see where we can improve things, because we know that the earlier you start modeling and working with the building mass and these issues, that's where you can make the big impact. And this is a very rough calculation based on a competition proposal, but this is kind of where you see how it's compared to traditional concrete and steel structure, where you can see the different building elements and then compare it in the 50 years lifetime. But we can still see that in the 50 years lifetime, the energy is, of course, one of the big consumers. But what we are working with as planners and architects is all of this, the heavy building parts. And then to Stockholm, where we recently also won a competition about a life science building, which is this one here. And it's somehow finalizing the city center, the compact part of Stockholm here, and the conditions, the neighbors is this big transportation highways in the surroundings of the city center. And the building consists of one element, which is this zigzag shape structure of laboratories and workspaces, and two little buildings for professors and people who are working in this facility. And it's also supposed to be, or projected to be, a timber structure. And here you can see, of course, a lot of thoughts about the social sustainabilities, all the involvement, all the social activities is always a part of the projects that we do. Now my focus is on the structures. So, and again with these atriums where you can see all these chances where people can meet and exchange thoughts and ideas. And that's also that will also be a typical project where we have the timber lifted up on a podium in order to maybe for the parking, maybe for the basement situation, we have the concrete, but then the rest of it would be a full timber structure. And finally, and maybe a little bit more thorough, a little walk through this project. So it's a 34,500 square meter development. It's not a big one in our terms. We have our client is an investor called INA, and the developer is called Implenia. They're quite big in Switzerland. We are still working since a year, preparing to enter the SDE stage because they are struggling with budgets. because of the market at the moment. We hope to get started soon. Anyway, so this is an example of regenerating brownfield, as Corwin talked about. It's an old factory area, a city within the city in Winterthur, where they used to produce locomotives, which is why we got those funny names, the Rocket and the Tiggerly. It's these two engines. And the area is like, as you can see, it's integrated in the city, but it's a brownfield area that is developed in certain stages. And the one I'm talking about, this one, the Lokstad, that was actually the master plan done by a known Swiss architect back in 2010, the master plan that won. And in that master plan, they indicated that there should be a tall building as 1 out of 3 in Winterthur as a focus point, a center point in the new development. And at the moment, all of the other plots are more or less developed. So our project is the last one. And the context is you might be romantic, but it has character, this context, because of these industrial buildings where the architecture is readable. It's no-nonsense architecture. And for some reason, there's a lot of brickwork in this area, in these factory buildings. And so this is the context that we started working in. And more or less, this was the situation before starting to develop the Lokstad. And then there was the master plan that we proposed, and we are here in that block. And the idea was, this is the volume from the master plan. And our idea was to try to merge the volume into the history of the industrial fabric and then cut it up, separate the buildings and create a space in the center that would be more open than the volume told us to do. So actually we somehow cut free the 4 different buildings and separated them. And that makes sense because in the brief from the competition, they all had different functions or at least different program. Those 4 buildings, a hotel, a family building and a student building, as well as the tower. And we also thought that by separating the buildings, we would make it more simple, but also more flexible in order to both to develop, but also to also for future refits of the buildings over time. And the client already had the ambition, they already studied this and prepared the building technique for at least for the tower, which I will come back to, as this so-called tube-in-tube system. And then we said we propose, by separating the building mass, that we can downscale the low-rise into an ordinary CLT and laminated timber building. Also, we created this transparency, permeability in the urban fabric that would increase the social sustainabilities. And we also, by taking the corners out of the buildings, we're also allowed to get more sun and daylight into the courtyard. Thoughts about public functions in the ground floor, community, and quite an easy pattern of accessing the building. Of course, utilizing all the roofs with greenery, to create biodiversity as well as the courtyard. And this is the overview of this. And again, back to this kind of permeability, which was something that broke with the program and the brief to make more connections in the local area. And this is an image from inside the courtyard where you kind of tie back to the old buildings that are staying in the area, activating the neighborhood. So looking a little bit into the building, very open ground floors with as much public attention, retail, lobbies, workshops, and restaurants. And this gap in between the buildings, it's all timber, it's only 5 meters. The 5 meters is some kind of a global, or at least it's a European standard for the fire spread or the jump, in order not to have very expensive material, at least in the windows. And again, creating areas for semi-public use for the tenants on the rooftops here, creating amenities for the many inhabitants in the tower. And on the very top, on the penthouse, there's a function, we don't know what it's going to be, a public bar, cafe, restaurant, whatever. It's a demand from the city. And this is how it ties back into the... It's difficult to see because of the daylight, but here, so it shows that our material somehow ties back into the local context, connecting the history with the new build. And this is the only interior we delivered in the competition, but it shows the intention of the project that we actually want to explain the structure in a very honest way. So what you see here is actually the structure, the supporting column. What you see here is a part of the beam, an upstand from the beam, and a little bit from the other side. So it's quite simple, quite honest. And the slab is also a part of the composite slab. A bit about the structure. So this is actually, they did a lot of investigations together with the university in Zurich and a local, not a local, but a Swiss engineer, Waldgal Marini, that they have developed the system for a couple of years. And this is more or less what we got out of the brief, that it should be a system like this. And then we started working, having the inner core, which sometimes are cast in concrete, but in this case, everything is timber, like old skeleton framework. And then connecting with the outer tube. Also, that's more known in timber structures at the moment, that you have the outer tube and the slabs and timber. And then showing how it looks when they did a lot of tests in the ETH in Zurich. It's been tested, it's been documented for a couple of years how to do this new system. And these guys here, they're very massive beams. They are similar. It's plywood. It's LVL. A lot of thin layers of plywood glued together, similar to what we know from tabletops. But this is just 40 centimeters times 90. So very big dimensions, heavy dimensions. And then the attempt is to somehow glue it together, tie it together in the knots with as little as possible concrete and steel. And this is the slab, how they proposed the slab construction, a 5 centimeter thick plywood board with a little bit of profiling for these rods that would keep the distance in this composite slab. And then it's filled with insulation, and on top a little concrete cast, maybe it's 12 to 15 centimeters on top. And then you have a composite slab that somehow uses the different materials where they are best, the tension and the compression. And by doing that, they already have these calculations that it's, you can easily read it, that it's almost a third of CO2 we can do with the new system compared to steel and concrete. I think I've reached my time, but I will just flip through these very fast. So very simple system. We celebrate the structure. It's quite simple, rigid. But then the facade, we create a more vibrant facade by just rotating every second floor by 180 degrees. And then you get a pattern that is not as stiff as you could have imagined, but you get a more lively pattern in the facade. And we have the options of doing a lot of variety also in the units, duplex, single, and dual aspect apartments of different sizes. And they can be combined in many different ways, and which is, in our belief, also very sustainable, that you can actually vary this also in the future. So this is, this is a typical plan, and doing a tall building, we always think about how to separate the different layers. So in the low rise, we have balconies on the outside because it could activate also the city life by having life moving out into balconies. And then further up, it looks like this. And then further up, we would shift into having lodges, which would be inside the tower, because it's when the higher you get, the more uncomfortable it gets with the wind conditions as well, and the height issue as well. And we think that the facade system is also a prefabricated system, similar to all the rest, which is cladded with a burnt clay terracotta. It's not, if you think about it, we could have maybe found a material that was less carbon heavy, but the fact that it is lasting forever, terracotta is a thing to consider when you choose the facade material, because if you have very big proportions, we can disassemble these elements in case we cannot, but in the next generation can do it, and then it can be recycled and reused again. Just a little bit about this ties back to the local material choice, just done in a modern way. So this is what you have in the area, and this is the new interpretation. And again, it's a very simple aesthetic pattern. We celebrate the structure because this is what the project is about, this new technology. And then we just make a few variations in the structure of the facade. And so finally, just a few remarks on on the way forward. So I think as we do today, it's so important that we all share our knowledge when we have knowledge, in order to spread the knowledge and the know-how. We know that every cubic meter of wood stores approximately almost a ton of CO2, and we can for sure grow this resource if we start, let's say, 60 years ahead. Then we can continue growing. So this is an important fact as well. It's not something that we will run out of, this resource. I think this was more or less the last slide. Yes, thank you.
So thank you very much, Mats, for your presentation. I think you carry on with the keywords refuse, reuse, remix from the first presentation. Our second speaker is Mr. Johannes Rebhahn, Head of International Timber Projects from company Wiehag, who will share his know-how and specifics of timber constructions from reference projects all around the globe. Johannes studied structural engineering at TU Graz and Lisbon before joining leading Luglam providers Wiehag in 2002, and is currently head of international projects with responsibility for all jobs outside of Austria and Germany. I think that's it from my side, and the floor is yours, please.
Yeah, thanks a lot, and thanks to Mats for promoting timber. That was quite appreciated. Yeah, pushing the boundaries is in timber construction is the title of my talk. I want to show you what's possible in timber and what's even more possible, so that you're not asking about if you can make a 10-story building in timber or not, and just to make it clear that what's possible in timber. The background from myself is I'm working at Wiehag. It's a company in Austria, in Upper Austria. We name ourselves as the pioneer in timber engineering, simply because we are the pioneers in timber engineering. We started 1849 already as a small carpentry in a small village named Altheim. And since ever we built the timber buildings with the longest span or the highest buildings, let's say the reference projects, the milestone projects for the timber history. In 1966, we built already a building with a clear span of 100 meters. It's still in use. It's an exhibition hall in Klagenfurt. Around 2010, also worldwide celebrity architects realized that they can make their big projects, their organic projects also in timber. They don't have to use always steel. We are working since ever, or since 25 years with CNC machinery and therefore also with 3D design. And that made it possible that we make projects like Norman Foster's Crossrail Station in London or Richard Hodger's McKellen Distillery in the Highlands. Around 2018, you may have realized that timber went also vertical. So far, timber and glulam was famous for long span, for big structures, swimming pools, sports halls, and so on. But around that time, a lot of buildings exists also as multi-story buildings. And we proved again as pioneer and built the tallest timber hybrid building currently in the world with 86 meters in Milwaukee, or Asia's largest timber building by volume, or Australia's tallest timber office. And the development was like that. You can imagine we always ask the client, maybe you can build it in timber, we fight it against steel, we fight it against concrete. And now from that, let's say, freak show, from this niche market, what we have been in this timber industry, it's now going into the direction of mainstream. And that led to the decision that we made a new factory line focused on multi-story buildings, on high-rise buildings. It's still in the same place, but that's now the most modern line for making high-rise buildings in timber. We do not only produce timber, we have a real holistic approach. From our DNA, we are engineers. We have 25 engineers in-house. And so we do early stage support. If you as architect want budget costs or feasibility checks, we can help you. If we are the lucky contractor on that job, we do then the full engineering and design, because normally the timber company is responsible for the engineering, for the structural engineering. It's a bit different to steel structure or concrete structure, where an external engineer takes the responsibility. In timber, normally the timber company is taking that over, and it's the timber company's insurance who is backing that up. We do then, of course, the manufacture. We have project management, and we deliver it wherever it is in the world, and we can install it also. Where are we? Not far away from here, 350 kilometers to the west, somewhere in the middle between Munich, Salzburg, and Vienna in Altheim. And we have a few sales offices also around Europe. What is necessary to do a project in timber? Of course, we start with the engineering. As said, we have a strong in-house design team. And so you start with the total stability, with the member design, the connection design, which is most important in timber projects. And then you do your 3D CAD model. We even have some specialists on parametric design if it's getting really complex. And this engineering is simply the most important part. I think there are a lot of architects in the house, and I can just recommend to bring a timber specialist early into a project because it's not fruitful, and everybody's frustrated if you're running several weeks in the wrong direction. And that might be if you as architect, together with your engineer or the client's engineer, are designing isolated timber building, and then at the end you realize it doesn't work, or the industry cannot make it. So early engagement of timber specialists would really help every project. And it's a teamwork, obviously. So as I say, don't work alone, work with timber companies at an early stage. We normally make a kind of design workshop in the company, so to bring all together. We can make a mock-up, you see like that. That's a very small detail of a huge job. And yeah, that really helps in the progress of the meeting. You learn each other together, you avoid email wars, you can talk each other after a workshop like that. And it makes definitely sense. Once the design is over, which is definitely a long period, can be a few weeks or a whole year, depending on the size and complexity of the project, we procure sawn timber. We source that quite locally in a radius of 200 kilometers. That means it's from Austria, from Bavaria, or Czech Republic. And we kiln it, and that kilning, that drying of timber needs a lot of energy, but we have a lot of energy. We don't care about the oil price, the gas price, because we have it in our own. So all the chips and the sawdust is transferred to heat and even to electricity with a kind of gasification process. The finger jointing is kind of the miracle of glulam. You can cut out big knots or failures of a board and glue it together, so you have a homogeneous quality of timber, and exactly that quality that the engineers are designing with. You apply a glue and a hardener, and then you can shape it and glue it in different shapes. This already CNC controlled. These pressing beds can be curved, can be straight, whatever you want. And then, of course, the CNC machining, which is really exact to tightness tolerance. So timber construction is more exact, more precise than steel or concrete structures. But of course, we have always to manage the interface between steel and concrete and steel and timber. Pre-assembling of steelwork is really, really important because on site we want to have a kind of IKEA flatback system. Just stick it together, put some screws on it. If you start to implement steel parts on site, you made something wrong. Or if you see a chainsaw on site, you can be also sure something went wrong. So it's really just getting the sticks on site and put it together. Also from health and safety point of view is, of course, it's very important that it is then easy on site. We use also cross-laminated timber in our projects. We don't produce them because there are plenty of CLT producers in Austria. I used a picture from Stora Enso. I think someone of Stora Enso is also here. And yeah, because we work a lot of also with them. Normally, cross-laminated timber manufacturers don't have any engineering know-how, so the engineering know-how is by the other timber suppliers. Yeah, once it's produced, we have to get it on site. It can be impressive like that, 65 meter. That went to northern Germany. This is daily business, I would say, 30, 40 meters, going straight across the roundabouts, having an escort car on the back, on the front. So this is really normal business. Yeah, also container. We work quite often also overseas. That was a container going to Singapore, the last one during the pandemic, during the Suez Canal blocking. So we were quite happy once the last container left our company. Yeah. We do even some jobs with helicopters in the Alpine regions. So logistics is quite important and has also influence to the design, because you have to decide where you make your joints and to reduce maybe the transport lengths. And then on site, we install it. It's not much difference to steel installation. You have your cranes, your mupes, cherry pickers, and a few lads who install it. But we maybe have to get used to pictures like that in 80-meter height, working on a timber structure. Yeah, that was just a quick overview to see, okay, what's involved in doing a timber business. And now I want to show you some references. And I start with the real huge and complex references for which we are famous for. The real, let's say, celebrity jobs in the timber world. One is that, the McKellen Distillery in the Highlands, close to Aberdeen, designed by Richard Rogers. It's one of the most complex timber roofs in the world. It's hard to get the feeling on this slide. You really have to be, and if you're in Scotland, you can't miss it. It's one of the most important visitor attractions already. So it's a new distillery, including a visitor center. It's a cathedral to whiskey, but also a cathedral to timber. Norman Foster's Crossrail Station in London, 300-meter long, so the longest timber building in the UK. A combination of ETF pillows and glulam. It's also a public space, so you have restaurants on both sides of that tunnel. It's a station for a new train line in London. So again, worth a visit. If you're there, you can simply enter to it. Another huge project done in Israel, 105-meter diameter, so really long span structure in a dome structure. So sometimes it's a pity that you need a roof on top of it, but yeah, you need that. And that's our current baby, the world of Volvo in Göteborg. Volvo is producing only with steel and metal since ever, and they decided for a timber building. They make their new world of Volvo. It's a meeting point. It's their museum. It's a place where all the time is something going on, and their most important project is also a cooperation with the city. They want to create a new tourism attraction. I don't know if you realize it, but it's 110-meter diameter. So an inclined disc standing on 3 tree columns, more or less. So the architect, Henning Lassen, by the way, wanted to create a disc standing on 3 tree columns. This is one of the most complex and largest timber projects in the world. I mean, you know, there are big ones which are simple and small ones which are complex, but this combination of really size and complexity is really unique. The staircases in that case are not structurally important for the timber. The timber had to be really self-stable. The architect didn't allow bracings in the facade, which is a pity for us as structural engineer, but we simply have to accept that. By the way, we don't question the architect. We lost that behavior in the last 20 years. At the end, the architect has right. And we like to work with architects, especially, forgive me the word, technically naive architects who start with a sketch and ask us, is that possible? Is that 150-meter span possible or that? And if we think on the first few, that could be critical, then we are even more motivated. Because if we would build always the same, what we know that it works, it would be a bit boring. So we need really the architects to challenge the industry. And I think that's a quite good cooperation between architecture and industry. You see here, quite important timber connections. Models like that need a while. So 2 engineers worked for 1 year to create that model. By the way, it will be opened in 24. Really huge connections. Timber design means most of the time connection design. So the member design itself is not the critical thing, but how to transfer 2,600 kilonewton meter with timber is critical. And how do you hide it? How do you embed it? Because normally the architects don't want to see it. There are some who want to express it, but the majority says, please, I only want to see timber, but you have to transfer a lot of loads. And this is the result. It's kind of a signature detail on that job, that curved corner connection. Huge deflections, critical points, and exactly in the point where you see the red area, we had also a moment-rigid connection, kind of star node where you see that 3 points. And boys, I tell you, that turned out as a real beast. So that can look like that, really complex. Just to give you a size, so this is a project manager and engineer. So it's really tricky to make these huge connections. A view from the top, from the bird's view. By the way, all these projects can be found on the internet. You find several videos. They won so many awards. So they are real milestones in not only in our company history, they are milestones in the timber history. And that's then the result, so you don't see any steel. A few pictures, Again, you can't miss it if you are in Gothenburg next year. Good. That's a final rendering where you see that tree structure of that impressive project. So that was, let's say, a series of really huge and complex projects. There are just a few in the world of it. Normally, they land automatically on our table because there are just a few companies able to do that. But we can't survive from these big projects. If they are, shifted for 2 months, we would be empty in the factory. So we need also a lot of medium-sized, small-sized standard jobs, which I show you now, like a typical swimming pool in Ireland, or quite famous swimming pool in England, which won a lot of awards, and it's really neat and clean design. You don't see any steel here. You probably know the Eton College, most famous college in the world, and we did just recently a swimming pool and a sports hall for them. Quite traditional design, but it's a traditional school. One of these posh colleges where money doesn't play a role, where the budget is really always unlimited, and the architect can be an architect. And the architect's baby was the glulam roof, so they made it really complex, 3D shaped in a lot of forms. This is also a strange structure. It's a cancer center in Israel done by Faro Partners. They are a real expert in biophilic design. And you can imagine if you are going into a cancer center, you're not in the best mood. So you want to have a real nice building, natural, curved, and so on. We just finished our part, so it looks on site, something like that currently. A small restaurant in the middle of London, surrounded from really high steel and glazed towers. City of Odense, I think we will hear something more about that today. We built with Kengo Kuma, another celebrity architect from Japan, the Hans Christian Andersen Museum, which was an important part of the whole city development, I think. A few pictures of that. So this is a series of, let's say, medium-sized, small-sized, but very, very architectural projects. Maybe some of you have been already here. It's in Slovakia, in Bachletka, a treetop tower. We built around 15 treetop towers around Europe already, and so also one in the north of Slovakia. If you go a bit away from, let's say, high-profile architectural, we do also industrial jobs, logistic houses, warehouses, and they can be also made in timber, and they have been done in timber since ever. This is the Stora Enso factory in Sweden, completely done in timber, 13,000 square meter, or a huge warehouse, logistic hall in Germany. It's quite often in Central Europe a combination of precast concrete and timber, but now more and more it's complete timber, so that the columns are also in timber. For instance, that one, 6,000 square meter done in Dublin, and we just secured a contract for further 30,000 square meter, similar style in Dublin, close to the airport. No, it's not architecture. The only guy who sees it is the telehandler driver, but it is sustainability. It's another story to tell, and you have to prove your sustainability nowadays. That's not so far away. Vienna Airport, built already 10 years ago, similar system, completely in timber, cantilevering columns, so there are really huge moments in the bottom of these columns. And just one sample of another industrial hall in Slovakia. We built for Mondi in Rudzombarok, the industrial hall. So for us, it's a bit a pity that we work so less in whatever Czech Republic, Slovakia, Slovenia, Hungary. If we work there, we are more or less moving with Austrian clients to that countries, but we are quite open to work more here. It simply didn't happen so far. And now the maybe main point of today, so what you are most interested is multi-story buildings. Multi-story buildings for future-proof urban districts is the name of your event today. And I tell you, these multi-story buildings are relatively easy in comparison to what you have seen before. It's just a column, a beam, and a slab. So obviously there are some details to solve, but I'm myself wondering why we haven't built it in the early 70s or so. the technique would be possible. We could have done in the 70s a thick glulam column, a beam, and a slab on it, but nobody asked us. So now you are asking us, which is good, and now we can build it. So we built the first multi-story building in 2007 already in the exact same system. So glulam column, glulam beam, CLT slab. It was a 3-story building in Ireland. It was a simple job for us, but now thinking back, it was really avant-garde, and it was something special in 2007. By the way, I maybe mix some words or whatever. Everybody's mixing words like multi-story, high-rise, skyscraper. So just a quick explanation. High-rise starts normally worldwide around 25 meter, might be 22 or whatever, 26. And the reason behind is simply the reach of the turntable ladders of the firefighters. So that's ended 25 meter, and then for higher buildings, you have other standards, other rules, other escape routes. Another step is then 60 meter, above 60 meter. You have maybe another 30 minutes of fire resistance requirement and so on. And yeah, skyscrapers. Skyscraper is not a technical word, but everybody uses it, and that starts at 100 meters. So hopefully we can do timber skyscrapers quite soon. We can do it already. We just need the right client. We start here with a few other references. For instance, one in Australia, completely in timber, 55 meter. In 2018, so it was the tallest timber building in Australia for a long time, still the tallest office building. So you see here 55 meter, just the first floor is in concrete. A typical 6x9 meter grid, which is quite efficient. You see some pictures of the production, so this is kind of cosmetics, what they are doing here in the factory to plug resin pockets or plug some big knots. You need to pre-install then the connectors, which are normally standard steel connectors, male and female connectors. And then that's how it looks on site. You put on the columns, you temporarily prop them, hang in the columns, and then the slab. And yeah, that's how nowadays timber offices looks like. Normally, quite often open or visible M&E. Glulam columns, glulam beams, fancy furniture, a lot of social areas, and they look honestly all the same around the world. So it's hard for the architect to get something different, but you will get your stamp, of course, I'm sure. That's a kind of building in an existing courtyard. Even the glazed roof was already existing, so we worked like the Egyptians. We couldn't use cranes. We really worked with ropes and so on. 10 stories, kind of a hub and new modern building. This picture is just showing that we can do, of course, also stairs and lift shafts. Everything can be in timber. The question is, do you really need it? Is it feasible? Asia's largest timber building, 13,000 cubic meter of mass timber. That's really a lot, yeah. And the university decided to make that in timber. So roughly 43,000 square meter gross floor area, a grid, quite rare grid, which is seldom 3 by 11 meter, but it came out of that radius. And you see similar system, glulam columns, glulam beams, and CLT slab. The columns are never longer, they're always just one story, because if you would make them 3 or 4 stories long, which is possible, you would have a forest of columns, and then you have to find your way with the beams and the slabs through it. So this is a question that we get quite often from architects or engineers. Why don't you make your columns longer? So just one story long. You see here typical traditional combination of staircases, lift shafts in concrete for lateral stability, and then the rest is in timber. Yeah, sun protection is quite important in Singapore. So you see how they help themselves. These are some pictures. Yeah, it's almost finished. I think in a month or so is the opening ceremony of that project. Yeah, next one is also finished from our side, but still on site. In Amsterdam, the DPG Media Group made their new office block 25,000 square meter, 6 levels. You see here a combination of CLT and concrete. That means these routings in the CLT are necessary to get the concrete and the CLT activated, so that they work together. And again, columns, beams, and CLT. You see here then the reinforcement and the pouring of the concrete. That is sometimes used if you have spans over 6.5 meter or so, then the CLT alone is too weak. Then you combine it with concrete, or if you have really high acoustic requirements. That's how it looks like. That I always recommend to architects, don't make a Swiss cheese out of our glue lamp. They didn't hear to me. So a lot of openings here and a lot of M&E, so it's better that you have that whether on top in the raised access floor or really behind. It's possible, it simply costs money. And that's how it looks. Yeah. Now to the current world record, the tallest timber hybrid tower in the world, 88 meter. You see, it's done by Corp Associates, architect from Chicago. And the bottom 5 levels are in concrete because this is a park deck, and the rest is in timber. And you see 2 staircases or lift shafts in concrete. So you know how Americans are. It must be the biggest, the tallest, the best. So they have a certificate for that. By the way, the Council of Tall Buildings, this kind of association who is watching that race of the highest building, highest timber building or highest traditional building. So you see a lot of information on that website about timber buildings also. Can be quite recommended. The grid is quite, let's say, small because it's an apartment. It's not an office, so 5 by 7 meter. And again, pre-assembling in the factory of the steel parts. It was 3 hours fire resistant required on that building, and they worked at a very early stage together with the fire authorities and the mayor to get that approved. So these things are possible if you start early and if you bring the fire guys early in the boat. And 50% of the timber structure is exposed. So that was the deal. They said, okay, please cover 50% with gypsum or whatever, but the rest can be open. And we have done a lot of testings, and the 3-hour fire testing is absolutely no problem. We even gave them a northern arrow on the columns and beams that makes it easier to install it, so they know where it is. It was a requirement from them. And proper trucks in the USA delivering CLT. And that's how it looks then on the floor. They bring on with the crane our columns and beams and then install it. Just a few impressions of that. Again, you find plenty of material in the web about that project, obviously. And that's not a rendering, that's real, so that's how it looks for the tenants. Quick of a summary. If you want to build a timber building, I point out a few key points which makes it more successfully, hopefully. As I said, early specialist input. If you tick that point, you can forget all other points because the specialist will tell you the other points, but let's follow through. So clarify the loadings at an early stage. If you have a change in the loadings, and if it's just 20 kilogram because you forget some M&E, you go back to square one, and nobody wants that, But don't be too conservative. Of course, it's easy to clarify loadings at the beginning in a conservative way and then put another 50 kilo and another 50 kilo per square meter on. So make really a realistic assumption and keep that through the whole project. And of course, clarify the fire, what is required. Is it 60, is it 90, is it 120? Is spread of flame and topic or not? We really need that information at the beginning to start through. Openings, as you have seen, openings for M&E. I know it's quite hard to clarify that because the M&E partners maybe not on board and they don't know what they need and how does it work. But it's a really important point to solve that at the beginning. Glulam grades, if you, have your own engineer who is starting with designing a glulam building, please keep it on lower grades, because all that buildings have a lot of cubic meters. They have 1,000, 3,000, 5,000 cubic meters, and you don't get in the higher grades. Sometimes the engineer are looking in the Eurocode, they see GL32H, yes, that's great, that's the strongest material, but they don't know that you have throw away, more or less 75% of a tree. I mean, you don't throw it away, you use it somewhere else, but you don't can use it for the glulam. So if you use the normal grades like 24 and 28, you can use the whole tree that you find in the forest. And it's easier to procure your contract. Single-story columns, I mentioned that already, just mention it here again because it's a question that comes quite often. Use standard shear connectors. The whole timber industry together with screws and connector industry is growing and growing, and there are more players on the market, so there are enough standard connectors. So if possible, use that. There might be some conditions where you can't use them because you have high tie forces or things like that. Then not, but try it first with standard connectors. Pre-assembling of steel parts, as shown, is really important. And the question about disproportional collapse, what happens if one column is kicked out? There are different philosophies. You can design it according to that, or you can say the columns are key elements. Clarify that, please, also at the very early beginning with the authorities, because that has a big influence to the engineering. Pre-cambering, some engineers, external engineers, think pre-cambering is a great thing, but not on multi-story buildings. Multi-story buildings means you have beams of up to 10 meters maybe, and that's really short. We do pre-cambering, but only for huge or long beams, let's say over 20 meters. But pre-cambering means you bring a complexity into the whole system, which is no need, and you don't improve the frequency, the acoustic or whatever with that. It doesn't make sense at all. Factory applied coatings are quite important because, even on the best weather, the timber will get dry during the installation, and that coating helps to maintain the quality. Have a think about logistics in inner city places. Of course, it must be then just in time placement and also on. So this is a real important factor. And think about on-site what happens with the other works, because maybe we as timber contractor are finished, but then there are a lot of other works, M&E, they use abrasive wheels, they use sparks, they weld around, they don't care about it. So make them really aware that this is timber and not a steel column. And if you're not able to make that, or if they are still damaging it, then you have to wrap the columns and so on. We talked a lot about, a bit about fire. But I'm more worried about water, to be honest. So water is the biggest enemy of timber. Therefore, as Mats has shown, the ancient churches and so on, they were all made in a way that water doesn't touch the timber. On site, during the construction phase, water is, of course, there. You just have to think about the temporary water management. How do you bring it away? How do you tape, maybe, or solve, or coat the timber. So that's quite important. And that leads me to my last slide. It should give kind of view what's possible in timber, pushing the boundaries, what are the limits, the current limits on heights, and that depends a bit on how you build your timber structure. If you're working only with CLT, with cross-laminated timber, so if you make, let's say, a CLT shoebox, you're depending on CLT shear walls and on walls with maximum 200 wide, and so you can build roughly up to 30 meters. If you make a full glulam frame, we recommend go up to 60 meters. I mean, you can go higher and whatever, but if it makes sense, it's a question. And obviously it depends always on the relation between the plane and the height. So a thin needle is not as stable as a chunky shape. But everything which is higher than 60 meters, we would recommend be rational, make a mix, make a concrete staircase, a concrete lift shaft to give them lateral stability. And the 150 meters is roughly the limit simply because of the ground floor columns. The ground floor columns get a lot of forces, and on 150 meters they get already really chunky. You can help, of course, here again with some other species, timber species, or even with hybrid stuff. But yeah, I would be happy if Bratislava has a 150-meter height building. You know? So maybe in 2 years I say it's 200 meter. Everything is possible. But I think this 30, 60, 150 meter is a good, is a good limit. Makes sense, and I get quite often these questions: where are the limits? On the right-hand side is a structure, a type of structure, which has no limit. You have a concrete core and then some mega floors, and the mega floors are made out of steel or concrete, and the timber is just in between. We're currently in the final of a tender for a 180-meter building in Sydney for that. So it's really a lot of timber in the structures like that. They can be built, whatever you want. And if you think what's currently possible in Slovakia, it looks like that. Looks like a doghouse, huh? So it's a pity. I don't know why. I mean, I can only guess. It's normally always fear because it's something new, but timber is not new. It's the mankind's oldest building material. It's the fairy tale of the three little pigs, where, of course, only the brick house was withstanding the blow of the wolf. These perceptions, and it's the fear maybe of the timber and steel lobby industry that the archaic is getting smaller. I don't know, but I can ensure that there are no technical, no logical reasons to stop at 12 meter. And I hope, I've proven that, you see that, what's possible, and thanks for your attention.
Can you stay on the stage?
Yep.
Thank you, Johannes. Please, can you stay on the stage because we have a panel discussion, which is actually happening now, and I will give it to Oli.
Pardon, mne teraz došlo, že na sluchatko.
Zatkaž si sem.
Môžeme.
Okay. So I will, if you allow me, I will switch to Slovak just for a while in this panel discussion. And I will give a first word to Pavol. Iniciatíva pre moderné drevostavby. Prosím ťa, Pavol, povedz nám viac. Čo to je, prečo to je a náhodou, ak máš náhodou nejaké slajdy, len čistou náhodou, tak by si ich mohol použiť.
Ďakujem za slovo. I changed to the Slovak now. Videli sme tie grafy, aj ten posledný, kde bolo tých 12 metrov slovenských a 150 iných. Naozaj situácia na Slovensku je taká, že drevené stavby z drevených konštrukcií sú obmedzené na prvú požiarnú výšku, to znamená 12,5 metra. Aj to sa podarilo dosiahnuť v roku 2017 po 7 asi rokoch jednania. Ale nadišiel čas, aby sme s tými drevostavbami sa pohli trocha vyššie. Rôzne pokusy investorov sa nepodarili v posledných rokoch, preto sme sa rozhodli, alebo boli sme oslovení ako Slovenská rada pre zelené budovy, či by sme nevedeli s tou legislatívou niečo urobiť. A tak sme otvorili minulý roku projekt Iniciatíva za moderné drevostavby. Zatiaľ máme cieľ dostať sa na 22,5 metra, čo by malo postačovať na to, aby boli investori motivovaní, hlavne v hlavnom meste a v krajských mestách, kde predsa len tie pozemky sú trocha drahšie, aby sa dostali aspoň na tých 8,5 poschodí. Takže stanovili sme si stratégiu, akým spôsobom by sme asi mohli ovplyvniť tú legislatívu, aby sme sa dostali vyššie. Prvá vec sú argumenty. Myslím si, že dozrela doba na to, aby sme skutočne to drevo začali používať ako stavebný materiál. Tých argumentov je niekoľko. Prvá vec, znelo to už niekoľkokrát, ale ja by som to zosumarizoval, udržateľnosť dreva ako stavebného materiálu. Máme hrdé ciele, ktoré sme si ako Európska únia dali na rok 2030-2050, ako to už bolo povedané, koľko toho vbudovaného uhlíka a koľko uhlíka pri prevádzke v budovách sa generuje. Bez zero carbon budov nesplníme cieľ roku 2050, pretože sú význačným generátorom uhlíka celkovo vo svete. Takže to opodstatnenie dreva, ktorý je udržateľný materiál a výrazne znižuje tú uhlíkovú stopu v budovách, je úplne jasné. Ďalej, hlavným problémom, jak tu už bolo naznačené, sú požiarne predpisy a tie protipožiarne opatrenia, ktoré musia byť splnené. Pri dreve treba povedať, že drevo, z ktorého sa teraz stavia, je iné drevo, ako stavali naši starí otcovia, keď si postavili zrub. Boli tu spomenuté celé panely a ďalšie moderné materiály, ktorých už tie protipožiarne vlastnosti sú úplne inde, ako boli pri klasických drevených stavbách v minulosti. Takže tento argument už by nemal platiť. Ďalší dôležitý argument je modulárnosť a rýchlosť výstavby. Bolo to tiež tu naznačené, keď sa robí modulárne, tá výhoda je nielen v rýchlosti tej stavby, ale aj v presnosti, v suchej výstavbe a v tom, že tá digitalizácia stavebníctva môže výrazne pomôcť práve pri takýchto druhoch stavieb. No a posledná vec, ktorú by sme nemali zabudnúť, je, že Slovensko je drevená krajina. Všade dookola máme lesy, takže naozaj môžeme stavať aj z materiálu, ktorý máme doma a môžeme byť v týchto drevených konštrukčných materiáloch sebestační. Takže to sú argumenty, ktoré v tomto projekte používame na to, aby sme ovplyvnili verejnú, odbornú a legislatívnu mienku na to, že je čas stavať z dreva. Druhý bod nášho projektu je aliancia. Ako som povedal, teda tie úsilia jednotlivých firiem posunúť tú legislatívu sa nepodarili, ale chceme ukázať, že toto je už celospoločenský proces. Že je to proces, kedy nie niekto, jedna firma alebo jeden investor žiada o to, aby sme sa dostali s drevom vyššie, ale je tu snaha alebo úsilie celospoločenské, to znamená v rôznych sektoroch toho priemyslu a nielen priemyslu, ale aj vzdelávacích inštitúcií, asociácií. Takže dali sme dokopy alianciu projektu, ktorý pozostáva jednak z veľkých firiem a investorov, ktorí majú záujem stavať z dreva, alebo ktorí vyrábajú materiály. Vidíme tam našich najväčších developerov, Gianty, Corvin, YIT, Imocap, ale aj veľké firmy ako Saint-Gobain, Payco, Knauf Insulation. A potom tu máme základňu odbornú, to sú podporovateľia projektu, ktorí pozostávajú z jednak architektov, akademických inštitúcií, máme tam právnikov, máme tam asociácie a táto aliancia sa dnes podpisuje pod tento projekt, s ktorým sa pokúšame tie naše stavby zvýšiť. Treba povedať, že projekt začal minulého roku a v tejto chvíli úspešne napreduje. Máme prvé dohody s prezidiom Hasičského a záchranného zboru o tom, že áno, ideme na to, tú legislatívu zmeniť a v tejto chvíli sa budú tvoriť odborné skupiny, ktoré pomôžu tú legislatívu zmeniť, pretože tá legislatíva je naozaj proces, ktorý nie je jednoduchý, musí myslieť na viacero aspektov a preto ponúkame aj legislatívcom naše odborné vedomosti, ktoré pozostávajú práve z tých ľudí z univerzít a z rôznych asociácií, aby sa podarilo urobiť naozaj legislatívu, ktorá bude funkčná a ktorá nám dovolí stavať vyššie budovy. No a posledný len taká poznámka. Vytvorili sme pozičný dokument. Je to asi v tejto chvíli 70-stránková publikácia, ktorá má pomôcť našej argumentácii v tom, aby sme sa dostali vyššie s drevom a pozostáva v podstate zo všetkých tých aspektov, o ktorých som hovoril. Čiže sú tam popísané stavebné materiály, sú tam popísané a argumentované ekologické argumenty pre výstavbu z dreva, argumenty efektívnosti, prečo stavať z dreva, sú tam aj ekonomické argumenty, keď začneme na Slovensku stavať, čo to znamená, keď budeme používať vlastné drevo, keď sme prípadne urobili vlastné prevádzkárne alebo výrobne na celé tie panely. No a potom je tam samozrejme aj dôležitá posledná časť požiarna bezpečnosť, kde sú nejaké návrhy a cesty, akým spôsobom máme upraviť požiarnu legislatívu, ak sa chceme dostať v tejto chvíli aspoň na tú druhú požiarnu výšku 22,5 metra. Takže to je informácia pre vás, že sa niečo deje v tejto oblasti a my veríme, že keď sa niečo udeje, tak potom budeme takisto prezentovať ako títo páni krásne drevené budovy na Slovensku. Po vašej prezentácii som mal dojem, že všetky budovy na Zemeguli sú drevené, koľko ich tu nabolo. Bohužiaľ u nás je len tá rozhľadňa, no, tak som si všimol. Takže veríme si, že spoločnými silami aliancie a všetky nás dokopy to drevo na Slovensku začne naozaj sa v tých stavbách objavovať.
Ďakujem veľmi pekne.
Ja len pripomeniem, vidím, že máme nejaké otázky, ale pripomínam do publika, že máme slajdo, čiže keby ste sa hostí chceli opýtať. A Marek, podľa mňa začni nejakou otázkou. Ty máš pripravené také tie otázky na našich hostí.
We'll switch to English or we will keep it in Slovak. It's up to us, but I think we can carry on in English if that's fine. So I will start with the first question from the audience, if that's okay. So what are the possibilities for recycling or reuse in general of timber after its lifetime? And maybe I will also add a question, what is the lifespan of timber construction? Maybe that's a question you have very often.
Okay, the lifespan is, as any other building, let's say, around 50 years. So the design working life, which the whole team is targeting, is 50 years. But yeah, it could be even longer. As long as timber doesn't get wet, there is no limit. There is no maintenance, there is no limit. So you see that on churches, you see that on old historic buildings. So it's really, it's not a difference, yeah. And yeah, we hear it quite often from people who don't want you to use timber. They say then, yeah, what about the maintenance? And they put then in their budget 10% more because of unknown maintenance or whatever. You don't need it. Yeah.
Matt?
I would say it's obviously that if the timber structure is, not to disagree with you, but if the timber structure is less engineered and has large dimensions, it's obvious that you could actually recycle it after the end of lifetime, because then you could modify it, you could treat it, and then you can use it again maybe in smaller members. So that's quite obvious.
So what is a typical way of reusing or recycling of timber after these 50 years or any after the lifespan? How do you usually reuse? I mean, except burning, of course, for energy reasons.
Since we are not there yet, because now we are just building the new timber projects, we don't know about all the glue members or sticks or whatever you call it. But we all know that you can tear down old buildings in the city, and we can reuse the larger dimensions easily. It's still intact.
I'll come back to the to your speech. As I was lecturing at NTU in Singapore 13 years ago, it was quite interesting for me that there is simple construction there in a high humid climate. So how the climate actually influences, for example, the lifespan or.
The office climate is the same all around the world. You want to have 20 degrees and 65% humidity. So it's not a difference. But if you use timber outside, it is definitely a difference. Here, they even used timber also outside as a kind of facade element. And if it's outside, yes, it's a limited lifespan. You use a different species, you use maybe large, but yeah, that's it. It's an exterior element. But if you compare it to a steel structure, a concrete structure, which is inside, so if you just change it in that way, there is no difference. And the climate inside is always almost the same. We also get quite often the question, what is going on in a swimming pool? It must be quite wet, but no, it is not wet. It is very dry in a swimming pool because they have air conditioned, they have 29 degrees and so on. So we do demolish already our first swimming pools built in the 60s or so on, and they are still fine. Yeah.
Thank you.
If I may, one question to Mats. There is a question from public. The timber research of ETH was by your initiative, or did they have an ongoing research which you have used for your project?
Could you repeat that?
The research of the ETH in Zurich you mentioned in your presentation. Was that by your initiative, or was there already an ongoing research?
I think, as I said, the initiative of developing this new technology was from the client. I think it started 5 years ago in order to find new ways to build a high-rise. So before the rocket project was tendered out into a competition, they already work on 3 buildings, similar, not as high, 2 on 60 and 1 on 80 meters. So it means that this research and development has been done in collaboration with a static engineer and the University of Zurich.
Thank you.
Yeah.
And you mentioned several times that one thing that is difficult to somehow procure to the people is the inner ambience, the feeling when you are inside the inner climate. What would you describe, or how would you describe, what is the utmost value for the people when you have a timber?
I mean, what I said is that it's difficult to explain in a photograph because it's a feeling, it's an ambience when you enter a timber building, a wooden-clad timber building, where you would you would need to stay there for a while in order to see the difference in the indoor climate and the work environment. The wood and timber has an ability to absorb and release humidity depending on the number of people inside a room. So actually, without having any technical equipment, you can actually have a good indoor climate if you have enough wood on the surfaces.
Thank you very much. Yes, this was a bit about re-explain me the picture, I know, but there was one question like this. And there is one which I would think it's more for Pavol, možno otázka, ktorá je skôr na teba, že čo je podľa teba hlavným dôvodom, prečo sa drevo nevyužíva viac pri občianskej vybavenosti alebo občianskej architektúre? To znamená, kde vlastne tá výška nie je až tak dôležitá.
Zopakuj to, prosím ťa, napriek prezentácii.
No, ja myslím, že som to povedal. Problém je, že sme na 12,5 metra a pri napríklad Bratislave 12,5 metra je malá výška na to, aby investori investovali a sa im to oplatilo postaviť. Čiže vypočítali sme si spoločné, že tých 22,5 metra, to je asi 8 poschodí, alebo 8,5 poschodia, to už by mohla byť dostatočná výška na to, aby tie investície pri tých bytových domoch boli vrátené a boli opodstatnené, aby sme mohli stavať z dreva.
Tomu rozumiem, je to otázka z publika, čiže neviem, či tomu rozumiem správne, ale aj by som predpokladal, že oni sa nepýtajú až tak na to, že prečo v podstate sa z toho nestávajú rezidenčné budovy, to je asi jasné. Skôr ako keby smerujeme, že tie príklady, ktoré sme videli aj zo zahraničia, boli predsa aj iné budovy, to znamená, boli to ofisy, boli to galérie, alebo teda nejaké verejne užívané budovy, kde v podstate možno až tento parameter by nemal zohrávať takú úlohu. Čiže...
No, aj tam tá výška je nejakým faktorom. Ja nie som úplne expert na tie protipožiarne predpisy, ale si myslím, že aj tam tá výška spôsobuje ten problém. V tejto chvíli hovorím, 12,5 metra naozaj je vec, ktorú keď sme si pozreli, akým spôsobom sa dá stavať u nás, jak sa dá stavať inde, je naozaj málo na to, aby sa masívne tí investori pustili do dreva a začali investovať. Treba povedať, že tie drevené stavby sú drahšie. Aspoň v tejto chvíli ešte a úplne sú drahšie vtedy, keď sa nestavia, keď není tu tá ekonomika v mest, že sa stavia veľa. Takže ja verím, že keď sa potiahneme vyššie, tak to bude mať dopad na všetky stavby. Veď dobrý príklad je budova ESETu, ten kampus, ktorý sa mal stavať, tak pôvodný plán, podľa našich informácií bolo, že 75% toho kampusu bude z dreva, ale tá legislatíva to obmedzila a sa to obrátilo, že iba 25% bude z dreva, 75% z iných materiálov, pretože jednoducho to na základe našej legislatívy nejde.
Ďakujem pekne.
I would switch probably to English again, and I would ask two questions which are, I think, very connected. And it's to you, Johannes. The first one is, I think it's a very question. We say we have enough timber, we say we have enough wood and so on. How does it work? I mean, this responsible sourcing of timber in Austria, what's the process? And do you think also about this aspect, that you use wood, but you also need to replant?
Of course, we have to say in Austria we are sustainable since 500 years. I mean, now there's all the certifications and the FSC certification coming from the rainforest and PFC coming more from the European side.
Sorry, I will rephrase. Maybe there was a question because you said you are also buying or purchasing the wood from another country. So
Yeah, of course.
that's your...
I want to say the Austrian forest industry have their, it was named the wood book since 500 years. It was born in the region around Salzburg, where we need a lot of timber for the salt mines. And so they realized, okay, that cannot go forever. And since then, every forest owner has to write and has to be sustainable. It's always a business for the next generation. So the father is planting the trees for the son. So it's their own interest, of course, to be sustainable and to replant it. And now with the certifications, they have the third party check, but they have been. It's not like in the rainforest where they simply cut it. And
so it's one of your rules. Any wood you purchase needs to have PEFC or FSC
course,
certification.
Absolutely, it's 100% PEFC. Yeah, that's everybody in the timber industry, and most of the timber industry has their own biomass plant, or they are close to a river. Traditionally, a sawmill was always close to a small river or things like that. So, for us, we were always green thinking, sustainable. I mean, it was natural for us. For us, it's now sometimes a bit rare that we have to prove that. Yeah. With all that certifications and all the things, and we don't have the environmental certification ISO 14000. Yeah. But the nuclear power station has that, yeah. Things like that. So, but sustainability is
Sorry, and the second question was the manufacturing process. The entire manufacturing process is happening in Austria.
Yeah, for sure. Yeah.
There was a second question which we don't have here, but I think it was there a while ago. Mats, question for you: the most challenging and the most beneficial on designing with timber from your perspective. It's not an easy question, but if you can simply answer.
I think I would say designing with timber would not be challenging. The challenge would be to get it done, so to speak, to find the actors in the market that can do it. That's the challenge in our local context and also here. Designing with timber, because it's the market is definitely based on concrete and steel. So finding contractors that are capable of doing it, that's the challenge at the moment. I think I talked a little bit about the well-being of timber structures and spaces. I think I would say that's the most fascinating thing about doing the timber design, because it's amazingly different from entering a standard concrete resi building, where you have the bad indoor climate, you have the bad acoustics, and you have all the paint, all the covers that you need to put on these materials, all these layers, and the timber structures, you can leave it much more natural, much less treated in the final product. So the qualities would definitely be to have a better climate, better indoor environment. It's the well-being of the people, and then it benefits, of course.
You obviously like challenges, and you obviously like challenges in your work. You're not afraid of anything. But anyways, is there anything that cannot be done, and you were challenged? For example, it looks like in Slovakia it can be done for some reason to go higher, but there is always a light in the end of the tunnel. Has there been anything in your references, in your experience, what is a limitation for timber, for example? Maybe that's also a question which comes into mind of people. What is a limitation of timber, if there is any?
I would agree with Johannes. It's about using the timber where it's well used, and the exposure for moisture would be if you would do a project where it would be exposed a lot for rainwater, for high humidity next to the water. I would say that would be the limit, but it's just looking back to old common knowledge or common sense and look back and see what did people do before. And if you do that and get to know that the old skills of building, the mastery of building from ancient times, then there are no limits. Only act with common sense, I would say.
Johannes, maybe the question was also for you. So what's the most challenging, what's the most pleasant, or if you prefer, which one of those examples brings up to your mind what you have presented today, like something what you found really challenging and you solved it, or the other way around, what you find the most pleasant when working on these projects?
The challenging thing is maybe really the interacting of the many parties. Yeah, so the architect, the clients, engineer, the M&D designer, and that ongoing working and the clashes check every second week. And but it's a challenge in a way, but it's also our daily business. And as said, when architects came with a really crazy design, we liked it. And if we see forces that we haven't seen in timber before, we try to solve it. And these are our challenges, and we are learning from project to project. So, And as Mats said, there are no real limits as long as you think in a way that you keep timber away from the water. Yeah. So just do it. Yeah.
After listening to both of you, and especially after seeing all those projects, amazing projects, like it makes us feel like going there and experiencing this inexplicable pleasure of the special features. Palo, čo by bolo pre teba to? Prečo vlastne presadzuje vaša iniciatíva, okrem toho, čo si už povedal, myslím teraz tvoju osobnú nejakú motiváciu, ktorá ti príde v prípade tých drevostavieb, alebo čo ti chýba? Prečo si myslíš, že je dôležité, okrem teda toho, čo je zjavné, alebo teda tá uhlíková neutralita ako hlavný faktor, ale teraz, keď môžem byť challenging, osobná motivácia.
Ten hlavný faktor, si to povedal dobre, sme rada pre udržateľné alebo zelené budovy a už v tejto chvíli asi málo ktorý materiál je udržateľnejší ako drevený. Ja pokladám troška za náš handicap, že sme sa skutočne nezaoberali doteraz drevenými budovami. Až teraz, posledný rok, kedy prišli tie tlaky od investorov a celkové od tej stavebnej komunity, že všade dookola sa stavia z dreva, na Slovensku sa nestavia, tak sme sa začali tomu venovať. Ale toto je naozaj hlavný argument. A druhý argument je aj to, že to drevo, jak tu už bolo povedané, drevo je príjemný materiál, všetci ho majú radi, tak je to proste niečo, čo prinesie taký iný komfort do našho bývania. Ja som sa troška aj podivil tu na, že vlastne všetky tie stavby boli z priznaného dreva. Tu na určitým spôsobom sa dá staviať, ale to priznané drevo je takisto nie veľmi, jak by som to povedal, vyhovuje požiarnym predpisom. Vlastne všetky tie stavby, ktoré sme tu videli, boli krásne, drevené, bez akýchkoľvek izolácií, bez všetkého, neviem, akým spôsobom to dosiahli.
Chceš sa ich na to opýtať rovno?
Yes, I would like to ask you.
Chcete reagovať?
Okay.
Would you like to react?
Easy explained. We know that timber burns, yeah. You maybe have done your own campfire at home, but I think you would not start with a 400 by 400 column to start your campfire. That doesn't work. No, you start with really small things, and you don't see that small things on a multi-story building. They are really chunky columns, chunky beams. Timber burns 0.7 millimeters per minute, so this is very good. You can calculate it. So this is the important thing, that it is predictable. Normally, firefighters prefer to go in a timber building because they know what's going on. On a steel building, it's a bit, you don't know when you have the rubber effect and when it collapses. So, and they understand it, authorities understand it. It's in the Eurocode, it's proven so many times. Timber doesn't burn faster or slower, it is in that range. And so you can calculate it, the fasteners are hidden. So the steel fasteners are protected by timber, and that makes it simply so safe. Yeah. And in some countries you have that spread of flame issue. and that can be solved with a coating. Yeah. So that has nothing to do with structural fire resistance with 30, 60, 120 minutes. It's just, if timber can spread on the surface or not. But on a structure, like a column and a beam, there is too less surface that it would spread, you know. You have a column every, 6 meters, things like that. So if you explain it in a logical way, and if you repeat it, they get it. But the first thing is always against, yeah.
And just one last comment. I think it's really also the legislation. Today our legislation is really not in favor, let's say, to be very politically correct. But in fact, I just had a discussion with an architect from Switzerland last week, and she mentioned in Switzerland it starts to be difficult to be really compliant CO2 rules and new rules, new legislation with not constructing from timber. So this is just a remark to the difference of legislative backgrounds we are coming from.
Yeah, I would like to just mention that the discussion can continue after the panel discussion. There are a couple of specific questions which are technical, and I'm afraid we would not have time to answer those sufficiently. So please continue the discussions after this official part. And maybe at the end, as before, some last thoughts which you would like to tell to the audience to take home. Maybe Johannes, we can start with you. If there is any, or you said everything probably. Nothing to add.
I wish you good luck with the negotiations and to the authorities, that you're allowed to build higher. 22 meters is a start. It's 4 or 5 stories. The majority of the buildings will be in that range. The picture that I have shown, these are spectacular, punctual projects, somewhere here, somewhere there. But the majority is in that range, in the inner city, 5, 6-story buildings. And we are here to help you, but first you have to solve the problem with the with the regulations. Yeah.
So Paolo, that's the job for you. In the initiative, Matt?
Yeah, I would just say that you should not be afraid of getting into designing timber buildings. I also think even though that we are now designing the world's highest, it's not an aim for me. It's just publicity in a way and pushing the limits. So I would suggest that you do a low rise, like 3, 4, 5 stories in timber. That's easily achievable, less engineered, and you still get the benefits of what I explained about all the good qualities of climate, of resources, of all the things that benefits our common future. So just do it and reach out.
Thank you. I think that was a perfect conclusion of the panel discussion. What do you think, Oli?
Definitely, yeah.
So thank you very much,
unless
gentlemen.
Paolo wants to add something. Chceš niečo ešte povedať, lebo sme ťa skoro obrali o možnosť posledného.
Ja by som len záverom, naozaj by som to chcel zakončiť optimisticky. Lebo vďaka tomuto projektu vidíme, že to ide. Už sa tvoria odborné skupiny, ktoré začnú tvoriť tú legislatívu, aby sa to zmenilo, a ja verím, že sa dopracujeme k tým drevostavbám tak, ako chceme. Nakoniec okolo nás máme toľko príkladov, že nemôžeme zostať nejakým ostrovom, a ešte dreveným ostrovom, kde všade dookola sú lesy a my nestaviame z dreva. Takže ja som optimistický a verím, že v nejakom dohľadnom čase sa pohneme dopredu.
Ďakujeme pekne. A teraz už asi naozaj záver tejto panelovej diskusie.
Ďakujem veľmi pekne. Takže teraz myslím, že si dáme trošku pauzičku, než prejdeme do 3. a posledného bloku. Ďakujeme.